Hi, this is video number 10 for things not working, and it concerns the process of calibration. And this particular video is called Calibration, Erosion Grid Imagery Behind the Output Centerlines. Okay, and let me go a little bit more into that. In this particular video, I'm going to show you how imagery behind the output centerlines works for calibration in MATLAB, so you get an idea of how it has worked in MATLAB. Secondly, I will bring up IRIC and show you the place for it and the need for it in the IRIC modeling platform. And thirdly, I'll have suggestions for how it might be implemented in IRIC. Okay. Starting off with MATLAB, I'll give you kind of an overview and then I'm going to jump to MATLAB here. In MATLAB we can create an erosion field. There's a dialog box where the erosion field can be imported or created, and there's also a dialog box where it can be edited and then saved for future use. So once it's been ready, made ready to use in this dialog box, it's saved, and at that point it becomes the active erosion field for migration modeling. Now I'm going to show you that now. After it's saved and the imagery appears on the input screen, as number 3 says here on your screen, then it appears on the output screen when you run it, and that's what we're trying to aim at. So let me show you the MATLAB screen here. We have a box for the erosion field here, and this is the erosion field that occurs, or the erosion dialog box that comes up. Now, I'm not going to show you how to create it here. Down here you can load an erosion field if you want. Then you can edit it. Once you've edited it, you save it. Now, once you've saved it, it shows up in 2 places in MATLAB. The first place it shows up is right here. Again, these are a little bit screwy the way that says that, but you see the erosion field that appears behind the input centerlines. Now, this is attractive and informative, but it's still not the most important of the 2 places that it shows up. Most importantly, it shows up on the output screen. Now you might ask, why is that important? And it's a good question. I'll tell you why. And I'm going to do that with an illustration by running the model. Okay? So we'll do a scenario. Sorry if these appear off the screen, but I'll bring them over. We're going to go from channel 1. We're going to go all the way from 1976 to 2004. And we name our scenario August 26 A. Okay, now you're not going to be able to see it run because it will keep bouncing back to the other screen. But trust me, it's got a screen and it's running, and I'll show it to you when it gets to 2004. Now, our first time period here is 1976. That's the starting point for our modeling. And the point of running a model, in this example, is to calibrate the model. That means we're trying to run the model from the first observed time period and see if we can make it migrate so it matches the final time period, which in this case is 2004. Now, in our particular model, although you may not know this, in the middle of that time period, in the 1980s, riprap was installed. Therefore, there was an important change in the erosion characteristics right in the middle of our calibration period. And how do you deal with that? Well, the MATLAB program is set up so that you can have any number of erosion fields appear not only appear, but establish the erosion characteristics at the appropriate year. Now, that's not the point of this video. And it's not the point of this particular project, but I thought I would point that out, and it'd be an important point to discuss in a future video. Anyway, the take-home message here is simply, and here is the output. It's gotten to 2004. And you can see that that erosion field that we now have here is different than the one that started. That's because this erosion field appeared in about, I believe, 1986. So we have two different active erosion fields. This one went on for 10 years or so, and then this one took over, and it responded to them sequentially. Again, not the point of this, but important to note. So this is what we want to know, and the take-home message here is that the image of the erosion field that's active appears on the output. And that's what we want to make occur in IRIC. The same thing. Again, how does that help? Well, let's look at a bend close up here as an example. Here's a bend. Now, we can see that it seemed to be migrating. Let's see, 2004. It's hard to tell which one's which here, but it's this dark blue one, in my opinion, that is the output center line. And it seems that it's responding quite well here to these limitations, which you can see I drew in and put there in order to hold it in place. So the important thing is that you need to be able to see what you're calibrating in order to see how well it's working. I'll say I don't need to say much more about this, how you need to be able to see it in order to be able to calibrate it and do an iterative process. You're seeing sort of the end of the process here, but you can see how as you go along, you'd have to know what it is. Okay, now I am going to go into IRIC. And move these off the screen for you. In IRIC, I am going to select an erosion grid, and then you'll see that it doesn't appear. Once you select an erosion grid, it doesn't appear anywhere. It doesn't appear on the input screen, it doesn't appear on the output screen. Anyway, I'll do a run, and you'll see it doesn't appear on the output screen too. Okay. Now, here we have our IRIC. We'll start a project. We'll use this project that has a center line already on it. And first of all, we select the option to reuse an erosion grid. So we go down to the erosion algorithm factors, and rather using a fixed value for the erosion, we want to import an erosion grid. And we do that here. And at this point, I'm going to input an ASCII file. I'm not sure if you can import shapefiles. It would be very important to be able to import shapefiles, because most people will make erosion grids in shapefiles. Anyway, we'll go here and we'll take this particular erosion grid that I've already created. We'll save and close. Now you can see after you select it, it doesn't appear as an image on the input screen. It would be very cool if it did. I mean, it would help us to see that we've got the right one. It'd be interesting, and it would give us confidence that we're on the right track. But let's get to the real meat of the matter. Let's do a run. Okay. Now, do you want to save this? Sure. Now we see it runs, and I'm tickled pink that it runs so fast. It's one of the areas, as I keep saying, that IRIC outpaces MATLAB by a long shot. MATLAB takes forever to do this. Okay, we finish that. Let's move that. We go here to see the output, and as in the other case, it doesn't appear on the output screen. Now that's a matter of where it's just it's not just not being cool, but it's essential to have it on the output screen in order to calibrate effectively. Okay, so I had some ideas about how that might be done in iRig. Let's close this and show you some of my ideas. Okay, as I've been saying, the important thing is to be able to see it on the output screen. With the output center line. And it would be important to have the erosion field that's actually being used. So how you do this in iRig is up for grabs. I don't know if there's something already in iRig that can be called upon to do the job. If so, that would be great. I mean, we found that for erosion field stuff, that there was something sitting there in iRig that was already capable. It had to be tweaked, but it was there. What would be really good is for whatever the active erosion field is, whether it's one that you've created in iRig or it's one that you've imported from outside, whatever, that the program would be smart enough to know which erosion field we're using and to display it for us. So that would save us a lot of guesswork. First of all, to even know that if what we had chosen was working, and then second of all, it's going to make our calibration possible. Now, that's to be a first choice is to have that be automatically show up. Number 3 here, if all else failed, having it automatically appear takes too much time to implement. And here I admit that I'm making the assumption that you could probably do almost anything if you had enough time. But at any rate, if that was too time consuming to implement, then we'd like to import the key erosion field as a background image. Now, there's 2 points that are important there. It would be very, very efficient if you could import it and the correct georeferenced projection would come and it would be at the right scale. In other words, you bring it in and it would lay on top of or behind the center lines. Now note, I have to tell you that I'm actually able to import an image of an erosion field now. It's clunky, it's hard to do, it's not something I would really want to ask anybody who was modeling to do it, but you can take an ASCII file, and right now I have to save it. Anyway, it's a complicated process, but finally getting it to a JPEG. But when you import it, it's the wrong size. And then you have to manually fit it to your center lines. Not workable. So two very important things to be able to do are to import it so that it was to the right projection and scale. And sort of corollaries to that, the formats that would be useful to import would be, first of all, the ASCII file, which is the legacy format of many erosion fields that we've made over the last 20 years. And then shapefiles, which is more convenient, and it's the format that most iRig people are going to use, and it also happens to be the format when you make an erosion field in iRig and export it, it exports it as a shapefile. So if you had to go around and import what you just exported, it'd be great to just pick it up as it exported. That's the end of this particular video. It's an important one, probably one of the most important things to do. Okay, thank you.